I want to move down to this. Let's say we did, just for the sake of argument, a new study. And we wanted to look in this new study of what I've got up here of people who smoked or who didn't smoke and whether or not it led to premature birth or not. Do you guys know anything about this? Does smoking tend to lead to this? Yeah, the answer is yes, it does. So we have how many variables in this particular situation? If you look at the screen. Well, they're actually not 4 variables. There are 2 variables, each with 2 levels. It's always a good question because if you have 4 variables, then they each have to have levels. We have 2 variables here. We have smoking status as one, and then we have birth status as another. So it's a 2-by-2 design. It's a 2-by-2 design. What are we collecting here? What do those numbers represent? What do they represent? Are they scores? Are they what?
Mother's smoking status and the weight of their children.
It's not necessarily the weight.
Well,
It's
term.
It's frequencies. We're looking at frequencies there. So if you have a frequency-based distribution, what kind of statistic did we say was appropriate to run on that?
Chi-square.
Chi-square. But the question would be, hopefully I'm recording here. Yep, we're recording. I need to get my glasses. Sorry. How is this situation a little different than the previous one? This is another kind of chi-square, but how is this one different than the question I asked you just a few moments ago about, what was it, burnout? What was I?
One variable.
So that was one variable, and what was I doing with that chi when it was the burnout situation? I was comparing your data to what? Chance, the critical value, just chance. So in a chi-square, it's called goodness of fit. You compare what you get to chance. It's one variable, and you're comparing what you get just to chance. Do you like Coke? Do you like Pepsi? I don't know if you guys go back that far. They used to do those taste tests. So kind of a frequency-based, it's one variable, it's a couple of levels, and you're comparing your results just to chance. Is that what we're doing in this situation? No. We're not comparing one variable to chance. What are we doing?
Comparing to another variable.
We're comparing 2 variables at the same time. This type of chi-square is called a chi-square test of independence. It's called a test of independence, also sometimes called a crosstabs. I don't know, did we do any crosstabs with? I don't think we did. I don't think we actually did. But this is called a chi-square test of independence and a crosstabs in SPSS. And in this situation, you want to figure out, does one variable depend on another? Are these 2 variables independent or are they dependent on each other? When you look at the data that I've put here, how does it actually look? How does it actually look? Does it look like one variable depends on another one? Yeah, because if you look at it, if you're a smoker, you were saying at the beginning of class, percentages, what's going on? If you're a smoker, a lot more, 90% had preterm kids. If you're a non-smoker, and I just made this simple example up, it's 90% the other way. So it looks like in this type of situation, with this chi-square, we would actually have the chi-square, what did we call this one? A chi-square test of independence. Would we probably be significant here? Yes, very much the case. So this is called a chi-square test of independence. We don't do this one out by hand because it's just a mess. And it's no fun. And we're here to have a little more fun than this. So this is called a test of independence, and this result would probably be significant. So if it was significant, would you say P greater than 0.5 or P less than 0.5 here? Less than 0.5 would be the situation here. I do have an article there for you, though. And it was the article, if you want to pull it up, it was BMJ Journal, Spontaneous Preterm Birth. Have you got that one on your screen or a handout? And I wanted to kind of go to that particular article. Do you want me to pull it up on the screen for you?
What was it called? Like in the file?
It says Kyle.
Okay, good. Thank you.
Yeah, kind of the Chi article. It's not table 1 that matters. Did I put table 1? No. Table 2. Take a look at table 2 in this situation. If you look at table 2, and actually let me maybe pull it up on the screen with my recorder here. See if I can do this without killing anyone. Let's see, was it this screen? Yeah, that one looks right. Let's see. The Chi article. Woohoo! So if we go down to table 2 and maybe, let's see, can I make this a little larger? I think I can. I think I can. Wasn't that a song from something? Thomas and the Train? No?
The little engine that could.
The little engine that could, thank you. Okay, that was my burned out group. They remember that. Don't worry, you can. You can get over burnout. Okay, so if we look at this particular table, if you look at spontaneous preterm in this situation, does it look like if you stop smoking or you're non-smoker, does that look potentially okay? Hey, you got a p-value here of 0.66, so the percentage here are about the same. So if you stop smoking or you've never smoked, it looks like you're going to be okay. But what about if you're a current smoker? You got 25 people who gave preterm out of 251. Look at the p-value there. Guess what they probably did in this particular situation? What kind of statistic? Says it right here. They'd get a chi-square. So if you're looking at frequencies, if you're doing research and you're interested in frequencies of things, chi-square is the most simple kind of statistic to use. It's considered a non-parametric because it doesn't have to be interval or ratio scale based. You can just look at frequencies. There's other ones as well. If you come across any questions with Wilcoxon or sign tests, there are a bunch of them. They're considered very simple and very basic. We can't answer a lot of questions. But here, is this important? Would you argue that even though it's a very simple statistic, that this is an important table? Yeah, it's showing that if you're a smoker, you don't want to be smoking when you're pregnant. So this is kind of the real world example of smoking and its impact on birth status. And actually we can kind of go down the list. Small for gestational age, birth weight, weeks, uncomplicated pregnancy. It looks like all of these things, the chi-squares, which they did, they don't report all the details, but do you get the idea of how to like look at an article and see was this a chi-square goodness of fit or a chi-square test of independence? This was a test of independence. So this is what they're basically looking for here. Any comments or questions about this? Does this help people out a little bit? I wasn't quite sure exactly what I needed to be teaching here, but I thought this would be useful for just a review. If you want to read any other part of the article and you ever have any questions on it, I've talked to the IT people. I'll put you on a roster. I do have a Mary Baldwin email address. So if you have questions about other aspects of this, or if you're doing any research that's chi-based, you want to send me a question, go for it.
Just real quick, if I'm reading this correctly, there's no way to distinguish between non-smokers and stop smokers?
Yeah, actually we have a few interesting things here. One result, birth weight, looks like it is a little bit distinguishable. Because notice the p-value they give right here. Do you see where it says 0.09? Do you remember what term I used to describe the 0.09 situation? It's marginally significant. So it looks like if you are a stop smoker, you still could have a birth weight a little bit lower. Actually, a little bit higher, isn't it? Yeah, a little bit higher if you're a smoker who stopped 3479 versus 3409. That's a little bit different. So it's marginally significant, you would term that. Some statisticians use the term marginal significant. Some people don't. I tend to be one that does. I don't like the one-tailed thing, though, because if it's one-tailed and it's significant, sometimes you can get a chi value that's pretty low and still be significant, and you run the risk of having false alarms. And we don't like to do that. We don't like to say something significant unless we really have evidence to support it. Okay, go ahead.
So just a question, because I didn't read the whole article, but so in the statistical methods section, they're talking about using a number of different tests, the NOVA t-test,
Yep.
Fisher test. But this table, you're saying this happens to be a part that's only based on the chi-square.
Yeah, so what I decided to do is I was interested in coming up, since my simple example was preterm birth, I found this article, and this article mapped to what I wanted to talk about. In other classes that we have, I'll actually come back to this. One of the more interesting things they ran here was something called logistic regression. But today's class is not on regression, but just to give you a little bit of a preview. Are you guys familiar with regression at all? In regression, we try to use predictor variables to predict outcomes like heart disease and things like that. They do logistic regression here. The word logistic is where the outcome is categorical. It's either this or that. And so they do logistic regression to see preterm or not preterm. Dropouts. You can do dropouts. You know, you either dropped out or you didn't. If you have a DV, a dependent variable, that's either this or that, you can do logistic regression. They do some of that in there, but I didn't want to go there here. But if you do have questions about these things, and in other weeks I will talk about this, you can send me email questions. I'll be happy to answer those in relation to the article. There are a lot of other things in this article that you could talk about, but we're not going to here because we have other fish to fry. Do they have fish fries up here? Do they have fish fries in New Jersey? I don't know. Maybe Pennsylvania. Okay. So that kind of covers the chi.